Hello everyone. And welcome back to Chemistry Education Academy. If you've watched our previous video on proton and the discovery of proton, then you already know that scientists discovered the positively charged particle inside the atom, but a major question still remained unanswered. If atoms contain only protons and electrons, why is the mass of an atom much greater than the combined mass of these particles? To solve this mystery, scientists made another groundbreaking discovery: the neutron. In today's video, we're going to discuss what is a neutron, properties of a neutron, why scientists believed another particle existed inside the atom, discovery of the neutron, James Chadwick's experiment, what is the atomic nucleus, discovery of the nucleus, importance of neutrons in atomic structure. So make sure you watch this video until the end, because by the end of this lesson, you'll have a complete understanding of the neutron and the nucleus of an atom. Let's get started. What is a neutron? A neutron is a subatomic particle found inside the nucleus of an atom. Unlike the proton, which carries a positive charge, the neutron has no electrical charge at all. That's why it is called a neutron, meaning neutral. The symbol of a neutron is N. A neutron has no electric charge, a mass almost equal to that of a proton, a location inside the atomic nucleus. Today, we know that almost every atomic nucleus contains both protons and neutrons. But scientists didn't always know this. For many years, the neutron remained hidden. Why did scientists suspect another particle existed? After the discovery of the proton, scientists began measuring the masses of different atoms. They noticed something strange. For example, hydrogen contains one proton and has an atomic mass of approximately 1. But helium contains 2 protons, yet its mass is about 4. Where was the extra mass coming from? The known particles couldn't explain it. Scientists realized there had to be another particle inside the nucleus. A particle with mass but no electrical charge. This mystery eventually led to one of the most important discoveries in modern physics. Discovery of the neutron. The neutron was discovered in 1932 by British physicist James Chadwick. Before Chadwick's work, some scientists believed that highly energetic gamma rays were being emitted from certain nuclear reactions. However, Chadwick wasn't convinced. He decided to investigate further. James Chadwick's experiment. Chadwick used alpha particles emitted from a radioactive source. He directed these alpha particles toward a thin sheet of beryllium metal. When the alpha particles struck the beryllium target, a new type of radiation was produced. This radiation had no electric charge and could penetrate matter very effectively. Next, Chadwick allowed this radiation to hit a block of paraffin wax, which contains many hydrogen atoms. To his surprise, protons were knocked out of the wax at very high speeds. If the radiation had been ordinary gamma rays, the protons would not have received enough energy to move that fast. After careful calculations and analysis, Chadwick reached a revolutionary conclusion. The radiation consisted of previously unknown neutral particles, particles that carried no charge but had nearly the same mass as a proton. These particles were named neutrons. Nuclear reaction. The reaction involved in Chadwick's experiment can be represented as beryllium plus alpha particle gives carbon plus neutron. This experiment provided the first direct evidence for the existence of the neutron. Significance of the discovery. The discovery of the neutron solved many scientific mysteries. First, it explained why atomic masses were larger than expected. Second, it helped scientists understand isotopes. Third, it completed the modern picture of atomic structure. And finally it laid the foundation for nuclear physics, nuclear energy, and many technologies we use today. Because of this remarkable achievement, James Chadwick was awarded the Nobel Prize in Physics in 1935. What is the nucleus? Now that we understand neutrons, let's talk about the nucleus. The nucleus is the tiny dense central region of an atom. It contains protons, neutrons. Although the nucleus occupies only a very small portion of the atom's volume, it contains almost all of the atom's mass. You can think of the nucleus as the core of the atom. Everything else, including electrons, exists around it. Discovery of the nucleus. The nucleus was discovered by Ernest Rutherford in 1911. Before Rutherford's work, scientists believed that positive charge was spread evenly throughout the atom. To test this idea, Rutherford and his team performed the famous gold foil experiment. Rutherford's gold foil experiment. In this experiment, alpha particles were fired at a very thin sheet of gold foil. Scientists expected the particles to pass straight through. Most of them did. However, some particles were deflected at large angles. And a very small number bounced back toward the source. This was completely unexpected. Rutherford concluded that most of the atom is empty space. He also concluded that the positive charge and most of the atom's mass must be concentrated in a tiny central region. This region became known as the nucleus. Importance of the nucleus. The nucleus is important because it contains almost all the mass of an atom. It determines the identity of an element through its number of protons. It provides stability to the atom. It is the site of nuclear reactions such as fission and fusion. Conclusion. Let's quickly review what we learned today. A neutron is a neutral subatomic particle located inside the atomic nucleus. It was discovered by James Chadwick in 1932 through experiments involving beryllium alpha particles and paraffin wax. The discovery of the neutron helped explain atomic mass and completed our understanding of atomic structure. We also learned that the nucleus is the dense central core of an atom. It was discovered by Ernest Rutherford through the famous gold foil experiment. Together, protons and neutrons form the nucleus and make up nearly all the mass of an atom. If you found this video helpful, don't forget to like, share and subscribe to Chemistry Education Academy. Thanks for watching, and I'll see you in the next video.